Okay, so this one is about tip over, so later you can study it by yourself. Okay, so this one is one of the question where to determine whether is in the this one is a motion effect. Okay, motion effect. So the question is whether it's in the first stage impending motion, or second stage neither of impending motion or motion, or third one motion. So which state is this? That's the question. Okay, I think let's try to do it together. The mass of the crate is 20 kilograms. Okay, with assumption of G equal to 10 meter per second square. Okay, the mass, the weight will be 200 newtons. So if I have to draw the free body diagram, it will be like this. The weight here, it will be 200 Newton. Okay, then beside that we have it here at the height of 0.2 meters. The width here is 0.8 meter. The height here, the height of the force given there is 0.2 meters. 80 Newton, 30 degrees, 0.2 meter. Okay, so because we push it to the right, because we push it to the right, so most likely, okay, because we push it to the right, 0.2, 30 degrees, then we can assume that a friction force will be, a normal force will be happening here. This one is normal force, and this one will be friction force, F, like that. The distance here will be X. Okay, and now we have to determine whether it remains in the equilibrium or not. Okay, there are several things that we have to check. The first one is impending motion. The second one is actually impending motion and the condition of the motion condition and the tipping condition. Those two conditions we have to check. So the first thing that we have to do, okay, we have to try to calculate using equilibrium first. Okay, using sigma Fy equal to 0, what we will have here is, if going up is positive, normal force N minus 200 Newton, okay, minus 80 Newtons sin 30. Equal to 0. In this case, we have normal force. Matthew, would you mind to help me to calculate for this? What is the value of N?
140.
Oh, may I?
Yeah, of course.
240.
240. Okay, thank you very much, Asher. 240 Newton. Okay, so that's the value of normal force, right? Then, the next thing that we're supposed to calculate is the friction force using sigma Fx equal to 0. Okay, using sigma Fx equal to 0 is if it's going right is positive, going left is positive, then what we have is friction force minus 80 Newton multiplied by cos 30 degrees will be equal to 0. So our friction force will be equal to 80 Newton cos 30 degrees.
433.
Sorry?
400. Oh, sorry. 40 under
80
root 3.
newtons. For 40?
40 root 3. Square root
40
of 3.
3. So what is the value in decimal?
It's
different.
about 1260
1260.
because
40.
oh, so wait. 680.
69, sir. 69.
69. Yes, it's logical.
Oh, I
69,
see.
right? Correct, right? 69, right?
Yeah, 69,
69.
sir.
Okay, 69 Newton. So friction force is 69 Newton. And remember here that the mu s is 0.3. And remember that in order to calculate for the maximum friction force, F max or Fs, right? We have to multiply it. We have to calculate it like this: normal force multiplied by mu s. Okay. In this case, our normal force is 240 Newton. Sorry, 240 Newton. Okay, 240 newtons multiplied by mu s. Here, mu s is 0.3. So what is the value of the maximum friction force, maximum static friction force here?
72.
72. Okay, correct. 72 Newton. Then, if we compare this with this, we know that the friction force, the actual friction force which is happening, is less than the maximum friction force. Correct, right? Azeb?
Yeah, that's correct.
So, which condition is which condition that is actually happening here? Azeb?
Sir, may I see the list of conditions earlier?
You're supposed to remember this.
I have a bad membrane warning, sir.
Do you think the impending motion is happening? No, right?
No,
Because
it's
the
not.
value is less than the maximum friction force, static friction force. Do you think that the motion is happening?
No.
No, as well, because the
It's
for the
much
motion to
less.
happen, right? The friction,
It should
sorry,
proceed.
the friction force supposed to be bigger than the F max, right?
Yes.
So later, the friction force, we have to use the Fk instead of Fs, but this one is have to be happening first. The friction force must be bigger. Sorry, the calculated friction force, must be bigger than the F max, which is not possible. That's why motion is supposed to happen there. So it means that the condition which is happening is number 2, right?
Yes.
So it's in the equilibrium condition, but not in the impending motion condition. So it's yes. Determine if the remaining equilibrium, it remains in equilibrium. Yes, the things remains in equilibrium. But the other thing that you have to check is the moment equilibrium, whether it tips over or not. Okay, because when we talk about equilibrium condition, it means that it must be in the equilibrium condition for the fx, sigma fx equal to 0 must be there, sigma fy equal to 0 must be there, and sigma moment must be there as well. And sigma moment will not be fulfilled if tipping over is happening. So we have to check whether tips over is happening here or not. Although most likely it's not. Okay, but we can check. Okay. When we talk about this, okay, then this one we can use sigma moment, right, at this particular point to check whether tipping over is happening or not. Sorry, sigma moment not at a particular point. I think sigma moment at this particular point. This one will be much easier. Sorry, this x. Yeah, I think it's better to use that sigma moment at this particular point A, at point A then. Okay, sigma moment at point A there. Okay, X. I think most likely for this one, the tipping over is not happening, but you can check. How to check it is by calculating whether X is bigger than 0.4 or not. Okay, whether X is bigger than 0.4 or not. That's actually the things that we have to calculate there in order to check whether everything is in the static equilibrium or not. Oh, I think this one is not as easy as that. I think we just use this A here. Okay, if we use this point as our point to calculate the sigma moment, so sigma moment at point A equal to 0 at this particular point. Okay, then clockwise is positive. 200 Newton multiplied by this distance is 0.4 meter. Okay, it's clockwise. Okay, and then plus friction force multiplied by 0.2 meter. The friction force value F is 69 Newton. This one is clockwise as well, multiplied by 0.2 meters. Okay, minus normal force multiplied by X equal to 0. Our normal force is, where we say our normal force? Normal force is 240. 240 newtons multiplied by X. Would somebody help me to calculate for this? So 240X equal to 200 Newton multiplied by 0.8. What is the value? It's supposed to be 80, right? 80 Newton plus 69 Newton multiplied by 0.2. What is the value there?
13.8.
13.8, yes. 13.8 Newton meter. Oh, sorry, this one is supposed to be Newton meter. Newton meter. Okay. So it's supposed to be 93.8 divided by 240. So what is the X value? The value for X. 93.8 Newton meter divided by 240 Newton.
It's
What
about
is the value of
0.4.
X? Huh?
It's about 0.4 roughly.
No. You cannot put it as about. We have to be exact.
To be exact, 0.39.
Huh? 0.39.
0.3908. You could
39. Okay.
make it
Meters, right?
0.39.
Okay.
Yes.
In that case, if it's 0.39, which means that the friction force later will be close to the the normal force, and the friction force will be close to the edge like this, right?
Pak,
Yeah.
it's not at the left of the CG, yeah, because sigma moment at A.
Sigma moment at A.
Yeah, so
Sorry.
distance,
Yeah. Yes, correct.
My bad.
Yeah. Yes, you are correct. Because we did it as
Jadi,
sigma moment at A. So and I just now I made a miscalculation. So just now the X that I calculate is this. You are correct. Thank you, Matthew, for correcting me. So that's the X value, right? Because we use it as sigma moment at A. So X is there. So the value will be here. The normal force will be here. The friction force will be here. So 0.39 from the left edge, because we use sigma moment at A. Okay, thank you, Matthew, for correcting me. So it means that tipping over is not happening. Over is not happening. So everything will remains in equilibrium. That's the answer. Okay. supposed to be good enough, right? I think later I will put several problem example for your homework, so for you to can practice, so you can practice for that with that. Okay, I think that's for today. Next week on Thursday we will continue our problem. I will give you several problem example on this friction topics. Okay, I think that's all. See you guys. See you again on next Thursday, and don't forget that next week on Friday. Next week on Friday at 2 p.m. we will have our exam. So please prepare well for our exam. And the topics is everything until the internal force, this internal force diagram and internal moment diagram. I think that's all. Okay. See you guys next week on Thursday. Bye bye.
Thank you,
Thank you,
sir.
Pak.
Yeah.
Thank you, Pak.
Thank you.
Thank you, Pak.
Thank you, Pak.
Thank you, Pak.